Okay, so hi. So in this video, we're gonna talk about understanding Le Chatelier's principle. So Le Chatelier's principle is a key concept in chemistry that helps us predict how a chemical reaction in equilibrium will respond to various changes. When a dynamic equilibrium is disturbed, the system will shift to counteract the disturbance and restore equilibrium. So let's explore how this principle works by examining the effects of different factors. So let's write Le Chatelier's principle. So Le Chatelier's principle states that if a dynamic equilibrium is disturbed by changing the condition, so the position of equilibrium moves to counteract the change. So this principle helps us predict how various factors such as factors such as concentration, pressure changes, concentration, pressure, temperature, catalyst or buffer, the presence of catalysts or buffers influence a chemical reaction in equilibrium. So these are factors that are affecting or influencing influencing equilibrium. There you go. So first, let's start with the concentration changes. So let's start with the concentration changes. So the concept here is that if the concentration of reactant or product is altered, the equilibrium will shift to oppose this change. So for example, the reaction nitrogen plus 3 hydrogen gas produces ammonia, 2 ammonia. So increasing nitrogen or hydrogen, concentration shifts equilibrium to the right. So the equilibrium is going to move it to the right. This is going to move to the right if nitrogen and hydrogen increased, so producing more ammonia, because if you increase the reactant, then there's going to be more reactant than the product. So equilibrium, Le Chatelier's principle, is to counteract the disturbance that has been changed, which is the increase of nitrogen or hydrogen. So the equilibrium will shift to the right. And in another example would be if it's going to remove ammonia, if it's going to be removing ammonia, equilibrium will still shift to the right. That's because when we remove this, then a product again is going to have more we're going to have more reactant than the product, because we removed one ammonia. So now we have to produced more ammonia here. So the equilibrium is going to shift still right, even if it's going to even if we removed an ammonia, because we can summarize this as this. So if it's increased, it is moving away from the increase, chemical stuff like that. And second thing to remember, if it's decreased or removed, then it moves toward towards the removed chemical, towards the removed. So we can towards, increased, away. So that we can have this as a note for us to it's easy for us to understand this well. And so we can move on for another one, which is going to be the pressure changes. So it's going to be the pressure changes. Pressure changes. There you go. So the concept for this is, in gaseous reactions, changing the pressure will shift the equilibrium to favor the side with fewer or more gas molecules. So, for example, the same reaction from here. So, if it's increased in pressure, then the system will shift to the right. So if it's increased in pressure, so same formula, we're working on the same formula. So if it's increased pressure, then it's moving to the right because there's a fewer gas molecules. But if it's decreased in pressure, the system will move to the left, will go to the left, as there are more gas molecules. So that's the idea for the pressure changes. So increasing pressure shifts equilibrium to the right because there's a fewer gas molecules. It's 4-to-1. That's why it's moving to the right. But if it's decreased in pressure changes, then it's moving to the left, as it's going to be 2-to-4. And so yeah, that's the idea for the pressure changes. Now we're gonna go for the temperature change. For the temperature changes. So the concept for this one is going to be the effect of temperature changes depends on whether the reaction is exothermic. So we have another word here, exothermic, and endothermic, endothermic. So or endothermic. So for example, let's use same formula, but we can write it down again. So nitrogen, we have hydrogen. Here you go, and that's plus heat. Yeah, we have to change plus heat. So increased in temperature, so we have to increased temperature. Increase in temperature, it will shift equilibrium to the left. Oops, I have to use to the left. Increased in temperature is going to move to the left, and decreasing temperature, decreased temperature shifts equilibrium to the right. So this goes there. So yes, so endothermic is the and that. There you go. And so let's go for our last but not the least is going to be our buffers. So have our buffers here, or the catalyst. So buffers resist changes in pH by neutralizing added acids, or bases. So example, in acetic acid and acetate. In acetic acid, also for example, in acetic acid, it's going to give us this, and we're going to have acetate ion plus hydrogen. So my eyes. Okay, so adding HCl, which is a strong acid, so if it's going to react with acetate with if it's acetate react with hydrogen forming acetic acid, it will shift, the equilibrium will shift to the left. Equilibrium will shift to the left. Equilibrium will shift to the left as so this is because they have to form more acetic acid if it's increased in here. If we added HCl, if we add HCl, then the equilibrium will shift to the left as we have to make more acetic acid. And if it's adding NOH, add NOH and acid sodium hydroxide, which is the strong base. This is a strong acid. This is a strong base. And so hydroxide reacts with hydrogen, and then we're forming a water, and this will shift the equilibrium to the right. So because to the right to produce more hydroxide. To produce more hydrogen. So that's just understanding and applying Le Chatelier's principle is like crucial in various fields, like from chemical processes to biochemical reactions in living organisms. For instance, in industrial synthesis, like controlling reaction conditions ensures optimal yield and efficiency. So like in biological systems, buffer maintain pH levels critical for enzymatic activities and overall cellular function. So yeah, in conclusions, like Le Chatelier's principle provides a powerful tool for predicting and controlling the behavior of chemical reactions under different conditions by understanding how changes in concentration, pressure, temperature, and the presence of buffers or catalysts affect equilibrium, and then we can manipulate reactions to achieve desired outcomes in both industrial and biological contexts. So yeah, we can just by applying in conclusion, by applying Le Chatelier's principle, we can predict how changes in concentration, pressure, temperature, and addition of buffers will influence the position of equilibrium in a chemical reaction. So this understanding is very essential for controlling reactions in chemistry or other laboratory processes. So thank you for listening.